Alright, in this one we want to solve some exponential and logarithmic equations. There are going to be two basic strategies. The first is based on the one-to-one properties, and the second is based on the inverse properties. For a greater than 0 and a not equal to 1, the following properties are true for all x and y, for which the log base a of x is defined and the log base a of y. Notice, if a to the x equals a to the y, then x is going to equal y. Similarly with the logs. If we have a to the log base a of x, that equals x, and the same with logarithms. So let's look at some strategies for solving these. First one is to rewrite the original expression and use the one-to-one properties. So let's do some examples. Strategy 1. 3 to the x equals 243 implies that 3 to the x equals 3 to the 5th, and therefore x is equal to 5. If a to the x equals a to the y, then x equals y. 1/2 to the x is 2 to the minus x equals 2 to the 5th, so by the one-to-one, minus x equals 5, x equals minus 5. Probably try to do another one here. Let's see, what shall we do? How about e to the x equals 14? Well, in this case, we've got the natural log of e to the x equals the natural log of 14, so x is the natural log of 14. Then we'll use the calculator to help us figure out what the natural log of 14 is, which turns out to be 2.639. Let's try a fourth example here. 3 to the x minus 1, and remember, 81 is 3 to the 4th. So we have 3 to the x minus 1 equals 3 to the minus 4, so x minus 1 equals minus 4, x is minus 3, if I did my arithmetic right. 5 times 8 to the x equals 325. First thing we have to do there, notice, is divide by 5. Then we get 8 to the x equals 65. Natural log of 8 to the x equals the natural log of 65. And so x is going to, notice how we're expanding, x natural log of 8 equals log of 65. And we use our calculator again. And so x is now 2.0075. Calculators are so handy. All right, so we've done number 1 using the one-to-one properties. Now, we can also rewrite an exponential function in logarithmic form and apply the inverse property. So let's see how we would do that. This is strategy 2. If we have 6 times 10 to the x equals 216, first thing we need to do is divide. 10 to the x equals 36, so the natural log of 10 to the x equals the natural log of 36. Using our laws of exponents, we get that x times the natural log of 10 equals the natural log of 36. We'll divide by the natural log of 10, and we'll go to our handy-dandy calculator to determine what the natural log of 36 over the natural log of 10 is. Seems like it's 3.585. Oops, I can't copy from the calculator. 3.583 over 2.303. And we'll have that equaling 1.556. Close enough. Well, how about if we have 6 to the 5x equals 3,000? So we start by taking the log of both sides. You notice how many times I take the natural log of both sides, because as soon as I get it that way, then I can use my laws of logarithms for the purpose of making it into a division problem. 5x is going to equal the natural log of 3,000 over the natural log of 6. And so we get 8.0063 over 1.7918. And let's divide both sides by 5 in a minute. I think I didn't solve for x there. So we've looked at strategy 1. We've looked at strategy 2. Now let's look at strategy 3. Which is rewriting a logarithmic equation in exponential form and applying the inverse property of exponential functions. Okay, so like if we have natural log of x equals e to the minus 9, then we go e to the natural log of x, which you remember is x. And so then in the calculator, we work it out. Natural log of x minus the natural log of 2 equals 0. So we get the natural log of x over 2 equals 0. E to the natural log of x over 2 equals 1. Notice how we had to do both sides there. Let's do a log base 10 of x equal to minus 1/2. All right, so we've got 10 to the log base 10 of x is 10 to the minus 1/2, and so x is 10 to the minus 1/2. Do you see how we're switching back and forth between all these forms? That is so important. Now, of course, we could solve a lot of this with a calculator, but we're looking at how do you solve it without a calculator. E to the natural log of 2x minus 1 equals e to the 5th. And so we've got 2x minus 1 equals e to the 5th. And we're going to get 2x minus 1 equals some 148.4. And we'll add 1 to both sides. And then we'll divide by 2, and we get that x is 74.7.